Hello, in this module we're going to discuss what is colour and how we describe it. Vision is a sense that allows us to know what's happening in the outside world without physically having to touch it. Vision is a remarkable sense. We can learn so much from the environment by what we see. We can see the colour, the position, the size, movement, and we also have to take into account that vision integrates with the other senses. The first thing you must realise is whilst the eyes play a part in your vision, you actually see with your brain. It's actually a cognitive process. Your eyes are just the start of the system. In fact, science is actually bringing artificial vision using your tongue to see with, and it is arguable to say that your skin may also play a part in your vision. The most important thing we're going to talk about today is colour. Colour is an interpretation of the electromagnetic energy coming from various objects, usually as a reflection. But let's take it back to the beginning. The first thing that has to happen is light has to get into the eye. It goes through the pupil, which changes size depending on the brightness of the input. We see things in order, both in time and space. The map is slightly different with each eye. These two images fuse, causing three-dimensional vision. So what we have is, in essence, a three-dimensional map which has a fourth dimension, time. There is a short delay from the information being processed at the eye to the information being processed at the brain. This may be important in a number of conditions, although it's not generally addressed. The first part of the system is the collection of information. The light goes into the eye and at the back of the eye, at the retina, is converted by the retinal cone cells. Now these cells are receptive to different colours, and they eventually provide a signal to go to the brain. The conversion of light energy into a signal is called transduction. The signals from the three types of cells are combined, and it's this resultant signal that it produces a perceived colour. We have to be aware of the light source. In most light sources, you'll have a light and possibly a reflection from the object being viewed. Obviously, in some cases, you may have multiple light sources, such as in a classroom or a workplace. It's not just the brightness of the light, it's also the position of the lights that are important. As daylight changes depending on the time of day, even the time may be important. So it's very difficult to get it right. And don't forget how cloudy it is can also have an effect. So it's virtually impossible to get a lens that is precisely correct for any given time. When we're defining colour, the two major things we have to be aware of are colour space and correlated colour temperatures. So what are they? Let's deal with colour space first. Around 100 years ago, it became necessary to be able to specify colour accurately, and a method of defining this called colour space was devised. It was first introduced in 1931, and it allows us to define colour as an XY coordinate, that is a graphical name for colour. There are different forms of colour space, but the 1931 colour space is the most commonly used. The dye industry still uses as a standard. We can also use the component colours, that is the spectra. This is extremely difficult to deal with, and not for people unless they're expert. So what I've shown here is a spectra of an eye examination room, together with its colour space position, which is XY 1931 0.33, 0.35, and also its colour temperature. As you can see, the XY coordinates are very much more precise than the other method. What they don't tell you is the composition of the light. So all methods have their applications. To understand about filters, we also have to incorporate the lighting. Lighting incorporates brightness, the colour, how white it is, and its position. The most common lighting we'll have to deal with is sunlight, but this changes depending on time of day and where you are. On this graph we can see how it varies depending on the time of day and the environment. The spectral distribution, or the different colours at different times, can vary quite wildly. Even moonlight has its colours, and then we have to combine with artificial light such as LEDs. There are two main types of LEDs, the warm and cool. They often have very different effects, and some people can work with one but not the other. Old-fashioned lighting, such as tungsten incandescent, is a very different transmission curve, but it's now been phased out. There are numerous other types of lights, such as mercury, low pressure sodium and high pressure sodium. When using a filter, it'll often vary quite significantly when you go from one lighting condition to another. By far and away the most common lighting in schools and the office is fluorescent. There are various forms of fluorescent, the most common being warm. They tend to have a very spiky emission curve with a bias in the yellow-red. Contrast this with an attempt to recreate daylight using fluorescent. It has a very different curve to the actual real daylight, but it gives the impression of daylight to the eye. But it does mean that sometimes a tint that's designed for daylight outside and daylight under fluorescent can be quite different. We need to take into account the lights being reflected and the different types of reflection, and also the absorption of the colours within the object. So we have reflection, we have absorption, and we have perception, and they all contribute to actually seeing an image. We also have the strange facility of colour to appear to be one colour and have quite a different mix of colours to achieve that effect. This is called the dominant wavelength. So we see things as one colour even though there may be a mix of colours. This is really important when it comes to tints, because two tints of vastly different effects can appear to be the same. We also have an interesting effect where the colours change under different lighting. This is called metamerism. It's absolutely critical when you're dealing with tinted lenses. This means that by changing the light, you change the tint too. So if you change the lighting, the tint may need to be changed. But there is an added problem within this area. The brain tries to make sense of it by keeping the colours constant. So if you change the lighting, the colour will still appear to be the same. In other words, there is a major problem with trusting an observer. You can't trust your senses. And if you try to trust them, you can't do it properly. So we can't do anything purely on what we see. We have to do it on measurements.